Okay, so thank you very much to everyone for joining us for this webinar. For those of you that don't know me, my name is Ben and I'm the sales consultant for KOREC in London. And I look after the distribution of technology sort of within the industry, including both GeoSLAM and Trimble as well. And today we're lucky enough to also be joined by Mike from GeoSLAM. So Mike, if you wanted to just introduce yourself.
Yeah, sure. Cheers, Ben. Hi, everybody. So I'm a product manager here at GeoSLAM. GeoSLAM is a company based in the UK, which is nice and convenient for everybody here. And I've been here for the past 3 years. I've got a really strong technical understanding of the products. So if you guys have any questions related to anything specifically technical, I'm more than happy to help you guys out. So I think Ben's going to run the next few slides, but you'll hear me chime in and out throughout the webinar.
Yep, thanks very much, Mike. So as you know, today we'll be looking at laser scanning and rapid data capture with sort of a format just to make sure that you get the most out of this presentation. Firstly, we'll sort of be talking about advancements in scanning and then look at the technology and the scanners themselves as well. So this will be followed by applications, case studies, and as Mike said, any questions that you might have. So to kick things off, it really goes without saying that laser scanning and sort of traditional methods of measuring have come quite a long way in the past few years. And the developments within the scanning world sort of allows us to capture more data and increase the speed of recording and also processing that data. I mean, traditionally before we would measure with everything sort of manually, but advancements with technology allowed us to use terrestrial scanners and now mobile scanners as well. So as I say, since then, scanning is now readily available for us to record point cloud with the GeoSLAM handheld devices, which essentially we seamlessly walk around the environment with, and they allow us to collect data at great speed and a simple, effortless way as well. So looking at the technology of the scanners, there are various scanners and options which we can use, and they can be utilized across many different applications, which we will come on to. So the hardware and the software, they really go hand in hand in order to enable us to sort of get the full end-to-end solution. And we'll be sort of going through this throughout the rest of the webinar, looking at both sides of it. It may be that you've already seen the handheld scanners, but we'll go through a brief sort of overview for you today, so you have a better understanding of the solutions and also their capabilities as well. The first scanner that we will be looking at is the ZEB-REVO RT. It enables us to record 43,000 points per second. And then all that data is being fed back to us live in real time, actually on the tablet as well. This also eliminates sort of post-processing, as the GeoSLAM scanner will register the point cloud during the actual scan as well. So this video is actually showing us what we're recording out on site, and it enables us to see the data build up around us to ensure that we haven't missed any areas, which also sort of in turn eliminates site revisits. So you'll see how we operate and visualize the scan as we're walking around, and it builds up on the fly. So you can see that red line there, which is sort of representing the trajectory and the path that we've actually taken through the building. This is then easily exportable as well to a tablet or a computer, and you can take your file formats out like LAT and E57 in order to then go on and interpret that data. So this is just an example of a data set here, which was actually recorded both internally and externally, because we can just move from the internal environment outside as well. And sort of, you'll see this sort of feed here, this LAT file has actually been taken into our Trimble RealWorks software. And then this is the data set here. Moving on to the GeoSLAM Draw software, which actually sort of allows us to go on and manipulate that data. So Draw can actually do an awful lot, but in its simplest form, it allows us to do things like create slices from the point cloud and draw floor plans with line work and that sort of thing. So here we're creating a slice, and then you get your ortho image that we can then draw on manually. So as I say, it can be done manually, or it can also be sort of semi-automated as well. So you'll see now we're going to use a vectorization tool, which will sort of automatically find those lines for us, and then we can complete the floor plan as well there. Another tool within GeoSLAM Draw, as I mentioned, there's a lot that we can do within this software, but I can come on to a bit more in more detail with each of you at a later stage, but we can also do gross internal areas as well in a minimal amount of time, because really these solutions, they don't only save the time on site as we've already sort of discussed, but actually in the office as well, trying to get that data and process that data as quickly as possible. Pass you over to Mike now, who will introduce one of the newest members of the ZEB-REVO RT as well.
Cool. Cheers, Ben. Yeah, so this is a new accessory that we recently launched for the ZEB-REVO RT called the Zeb Panel. As you can probably imagine from the image, we're using 360 imagery alongside the ZEB-REVO RT to help capture more fully the environment around you. I think one of the key things is that lots of people in the downstream workflows have not necessarily seen a point cloud or are really accustomed to using it. So having that imagery alongside the point cloud really helps them understand that point cloud better. So a kind of quick overview. As I said, the 360 panoramic photography is the real key thing of what the Pano brings. And there's kind of specific industries of why we built the system. It was mainly for residential spaces. So being able to walk around and do a property survey and then have this additional deliverable that the client could, I guess, essentially pay extra for, so that they could understand the point cloud a little bit better themselves. What's really, I guess, unique about these types of images compared to just walking around with the imagery on its own is the fact that we're actually using the SLAM algorithm to position the imagery. So in a more or less automated workflow, you essentially walk around the site, capture the imagery, and using the SLAM, we've also positioned all the imagery. So it's a very simple workflow, but also that positional information is spot on. So this is, as I mentioned, that really simple workflow. It is very much stop and go when you're in the field. So everywhere where you want to take an image, you simply just stop, trigger the camera, it will do a little sound effect once it's captured an image, and then you just walk on to the next area that you want to collect an image. So if you're in, I guess, a really complex environment, like we're seeing here in RealWorks, you might want to take lots of different stills, but you get that option completely yourself as a user. You can control how many images you want to capture, and then thus control the final data size as well. And then this is just a look at the data inside of GeoSLAM Draw. So GeoSLAM Draw, again, has a fully automated workflow where you essentially launch the program, and it will automatically grab all these images from GeoSLAM Hub and populate them inside of Draw. So then you can see your point cloud, view the images side by side in order to really understand what's in that space. So for kind of the 2D measured building survey work, it really helps you identify what else is there in 2D. But also if you're generating a BIM model, having that understanding of textures and features is really, really useful. And then a little bit about the ZEB-REVO specification. So yeah, as Ben mentioned, just above 43,000 points per second. The relative accuracy on the laser is plus or minus 15 mil. So when you're in a really small space, like a single room, that's the kind of accuracy that you would see across the site. And then where we've got the absolute positional accuracy, environment dependent is really, really key there. So SLAM uses the features in the environment to position itself, a little bit like GPS. So if your GNSS receiver is connected to lots of different satellites, you're going to get a really good reading. And the same is true for our systems. If you connected to lots of geometric features, so walls, doors, the floor, the ceiling, you can see lots of features close to the scanner. You're going to be able to get accuracies, between 1 to 3 centimeters, or here 2 to 3 centimeters. And by absolute positional accuracy, that kind of means from one corner of a building to the other corner of the building. So that's the total accuracy of that scan. Maximum range for the ZEB-REVO is 30 meters, so that the points that you're going to be collected, but it actually reduces down a little bit when we go outdoors, and we get interference with sunlight on this sensor, so we just trim that down to make sure that we're still delivering you good, accurate data. It's eye safe, big field of view, and the line speed's 100 hertz, so it's the highest Hakoyu that they deliver. And then this is just a look at the level of detail from RICS. And we actually sit in Band E with the ZEB-REVO. So it's this type of work that RICS bizarrely actually recommended it for us, but we sit in that 1 to 100 scale bracket, so Band E. So then this is the different sensor, so the ZEB-HORIZON. So the ZEB-HORIZON is more for that outside application. So as I mentioned, the ZEB-REVO, when it goes outside, kind of shrinks down to that 15 meters. Horizon does not. So we end up with up to 100 meters range for the Horizon. And then some of the points here, so intelligent point clouds. One of the big uplifts that we get with Horizon is the fact that we're also getting reflectivity. We're getting intensity data with SLAM, which is very difficult to do. Because we get that, it really helps you understand the features better inside the environment. Also, you know, if you're doing work outside on streets, around manholes, you might also want to get the road markings. You can only really do that with intensity. So it's really fantastic that we've brought that with Horizon. It is UAV ready. I believe we've got some examples coming up of that. So essentially, bolting the system to the bottom of a UAV means that you can really quickly collect UAV LiDAR data. Strongest ever SLAM and effortless data capture. These 2 points kind of come hand in hand. So by strongest ever SLAM, as I mentioned, SLAM is all about the features it can see. And with Horizon, because of that extra range, we can see so many more features that essentially you can run around an environment and it's effortless data capture. You don't really have to follow best practice as strictly as you would with the Revo, because the SLAM is so strong with the Horizon.
That's awesome. Thanks very much, Mike. Yeah, so as Mike said, I mean, with the Horizon, we capture the data very similar to as we would with the RT. And you see the camera at the front there. It also allows us to have that visual video recording as well that we can play back over the data as well for visualization. Mike mentioned sort of 300,000 points per second. So as opposed to the Revo RT, which is 43,000 points per second. But sort of going back to what Mike said in terms of actually mass data capture, and this video sort of gives a bit of an example of the sort of the scale that we can expect and scan using the ZEB-HORIZON. This was actually completed in about 24 minutes. Essentially, it's a whole town. So we can, of course, take any measurements from this, create drawings, elevations, topo information, all from this point cloud as well. So we don't really need to sort of limit ourselves when it comes to the amount of data that we capture and also the size of the project. And it also sort of gives us the sheer sort of scale of the time that we can save just walking around with it. Other enhancements as well, moving on to this slide here, with data capture and the GeoSLAM products, it gives us the easiest and quickest way of actually referencing the point cloud back to our survey control. So, you know, from myself coming from a survey background, this is actually quite game changing for me because the reference base is used sort of while scanning, and it just sits at the bottom of the handle. And then during the scan, as we're walking around, we can just hold it over one of our survey nails, and then that will record that point for us automatically. And then we can just transform that onto a known grid later back in the office as well. As Mike touched on, we don't necessarily actually have to hold the scanner in our hands. We can mount it onto a backpack, put it onto a pole, or even mount it on a UAV. So we can actually capture LiDAR data at height. So as sort of mentioned a little bit earlier, software needs to go hand in hand with the hardware just to ensure that we get the absolute most out of the data. So this is just a very quick example of the GeoSLAM hub, and as it sort of states, the hub is basically for all your data, and it also sort of has integration of the video, so we can store all our data within the hub and then view our data in there as well. So you'll see there with the red path, essentially we can click on any point within that path and then bring the video footage up at that point. So it's perfect for like inspections and interpretation and data analysis and that sort of thing. Moving on to sort of applications, we can actually use both these scanners across a huge range of different applications. And for me, I mean, the possibilities really are endless. They can scan in places which usually would be inaccessible and also do that in the least intrusive way as well. So there are tons of applications for using the GeoSLAM scanners. So please do get in touch if there's any that we don't discuss on this webinar. But I want to just run through sort of a few key areas where they're being used at the moment. So as mentioned before, one of the largest uses of the solutions is for floor plans. So both on-site and work processing the data back in the office is kept to a minimum. So as I mentioned, certain projects, they might be vacant, but others can also be occupied. So it allows you to be there for sort of the least amount of time whilst being least intrusive as possible, really. gross internal areas as well. So that just sort of also shows you the scale of the projects that we can scan. So large areas in minimal amount of time. As I mentioned earlier, we can just put the REVO or the Horizon onto a pole. So for restricted access, it gives us flexibility in order to be able to survey them. So we can put them on a pole, UAV, or a backpack, but we can even just pop a ceiling tile open and then put the scanner up and scan around. For me, I sort of came from the survey background, but from the construction side of things as well. So being able to monitor projects at sort of regular intervals is something that I'm actually fairly passionate about. The recording of that data as built information, but mainly sort of to make sure that projects are actually on schedule, absolutely crucial. And we can do this with the REVO RT and the Horizon as well. And then we can just scan as often as we like, so we know exactly what's being done out on site. Another one for me is stockpiles and groundworks. It can be extremely time consuming to measure and get an accurate result of stockpiles, and it's something that has to be done on a regular basis, but it can also be quite dangerous. It can be a dangerous task if having to sort of measure both with other traditional methods. It can actually be fairly dangerous. So with the Horizon and the REVO, we can just walk around the bottom of the stockpile, scan it, and then take that back into the software and get a quick volume calculation as well. Various other uses include the likes of clash detection, space utilization, forestry, facilities management, and we can actually take that data into our KOREC K portal software as well, which I can give you more information on at a later stage. So do get in touch, as I've discussed, with any other applications. It really is limitless, so we can talk through any of those that you might have. I'll hand you back over to Mike now, who will go through scan to BIM with the GeoSLAM products.
Cool. Cheers, Ben. Yes, we've got a few example case studies here that we've kind of gathered over our time. This is an example from Kansas in the US, where it was actually an old building as well, an old building by US standards. So I think it was built in 1926, and there was a major problem with asbestos, something that we deal with here in the UK as well. So having time to go in and capture is obviously a bit of a difficulty, and sending the right trained people for a long enough period of time to capture the data is always difficult. So having one person collect all the data in a single day was incredibly beneficial for these guys in terms of health and safety documentation. All of a sudden that becomes a much more easier task to handle, the fact that you can walk around in a single day. So they collected this data. I think there's some statistics coming up about how long it took them to generate the BIM model, but they did use this to generate a BIM model, and it was then used to renovate the space. So work out where the asbestos was, where the big damaging areas were, obviously to plan and take all that out, but then also how they're going to use this structure once it's been cleaned up. So they were able to start the process using the ZEB-REVO, but then they also went back and did the as-built check and design using the ZEB-REVO as well. This is an example of kind of 3D GIS stuff. This is obviously more specific to the ZEB-HORIZON, being outside and being able to collect data. But you can see here in a really built-up space, generally you get fairly poor GPS data in areas like this because you're connected to so few satellites. So being able to walk around to an area where you do have control and then take it into an area which is maybe have very narrow and tall buildings, you're still able to collect this data. And then this was then taken to model up and do elevations. So simply walking around a city block and you've got data to start working with. This is a fairly new example, so some of you may know this building. This is Boston City Hall in the United States. This was actually a really interesting one. The data was collected by the agency that generate the BIM model. So here we see the external scan. I know you can probably see some of the internals, but that's actually an open area inside of the building. So the exterior scan was done with the ZEB-HORIZON, and then the internals were captured using the ZEB-REVO RT, which is kind of a perfect combination. And as I said, this is collected by someone who is a BIM modeler, so not necessarily someone who would use traditional survey equipment, but they were able to capture data, compare it against control, which was on the outside of the site, and then start working on the data within 48 hours. So and then you can see the final Revit model. So really quickly, they're able to start working on their data. Okay, so this is this is just an example of how quickly you can, I guess, go to such a very small space and start creating your BIM model. So we've got, as Ben mentioned earlier, part of the software. So GeoSLAM, Hub and Draw come as standard with every single solution, so everyone gets access to the software. But we do have certain upgrade paths. And this is an example of GeoSLAM Draw BIM. So GeoSLAM Draw BIM is fantastic for new users of Revit, or for people that are maybe running on older versions of Revit that can't handle point clouds too well. And what it does fantastically is only bring the useful bits of data over to Revit rather than the entire point cloud. So you can see here we've got Revit on the right and GeoSLAM Draw BIM on the left, and we're able to select the wall element, the window element inside of Revit, and then there's a hard link between the two pieces of software. So now the user can go back into GeoSLAM Draw, pick on the point cloud the extents of that element, and these measurements and the location of these measurements are automatically pushed to Revit to speed up the whole process. So you're just picking on key pieces inside of the point cloud, and that is fired straight across into Revit to speed up the whole process. So if you're very new to generating digital twins and 3D models, this is a really great tool. But also, if you're sick and tired of using point clouds inside of Autodesk, it also really streamlines the amount of data that goes across into Autodesk. If you just hit next for us, Ben. Yeah. Okay, we'll see. There's a little video of it there, but Ben can send that to you guys if you guys need to. Okay, so some of the other case studies. So this is a British example from Omega Geomatics, and as Ben mentioned earlier, kind of low intrusivity, I guess, of being able to go in and capture the data and not disturb the space too much. So this is an example of residential rooms in an old person's home, and so obviously we don't want to have to evacuate everybody just to go in and do some scanning. The SLAM actually works completely fine with moving people, and we kind of ignore them in terms of features and positioning ourselves. But this type of scanning comes up time and time again. You know, if you're scanning large buildings and there are lots of different residents and getting permission for all the different people that are leasing different units, it can be very, very difficult. If you're able to say you don't have to evacuate anyone, you don't have to do anything, it makes that permission much, much easier because you're not disrupting people during their normal working hours. So this was then used to georeference the data. As Ben mentioned, we've got the reference plates, which really is a speedy way to register the data to global position, but there's also spherical targets and lots of different ways based on the tools that you already have. You could go and register the data. And so you can kind of see the turnaround time of being able to capture this data is really significant. So 2 site visits and drawings produced in 1 day. I don't know of another system where you can kind of get that kind of speed and velocity. So being able to capture that data so quickly is a massive, massive win. And then you can see they registered back to control, and they've ended up with an average accuracy of 15 mil, which is really good. They've clearly followed the best practices that we put forward, which is good news. Yeah. And then the kind of stuff that you can get as a deliverables. So gross internal floor area, this is something that's kind of bread and butter when you're doing the 2D measured building surveys. We can produce this kind of stuff from inside of GeoSLAM Draw. However, if you have different pieces of software that you use already to generate and publish your results, you know, maybe you've got these specific layouts that you use that with your branding. When we push our point cloud out, we are very, very keen to make sure that that point cloud can get digested elsewhere. So we do export the point cloud in all the open file formats, as well as publishing the DXF and DWG images from Draw. So you can go ahead and bring these images straight into here, speeding up all your downstream workflows that already exist. And this is an example out of country. So this is a company called Lifa based in Denmark. And part of the legislation that they have over there is floor space needs to be measured after the building's been constructed, so that they can make sure that for tax purposes and leasing to the next person, it's all correct and kosher. So this entire building was actually done in a single scan, not following best practices, but incredibly quick. And when all the GeoSLAM systems, especially the ZEB-REVO, really shine is when you're in these complex environments with many, many rooms. You know, if you think about doing it with different methods, maybe a tripod-based scanner, you would have to do a setup in every single room, and the time to do so is astronomical. Being able to just walk around a room within a few seconds and then leave is a complete game changer. And then this is just a look at the work that they did. So you can see the point cloud of the internals, and then they took this model into Autodesk and generated a Revit model from it. Obviously, that's not a single button push, and that is a very sped up version of generating the BIM model. But you can see they can take that information and start working on it straight away and create something like this.
So thanks very much, Mike. That was really good. And thanks also to everyone for listening to this webinar. I hope you've enjoyed it. I've enjoyed it. I'm sure Mike's enjoyed it. I just wanted to sort of sum up really and go over sort of what we've discussed in sort of the past half an hour, and just kind of go through it and see how these solutions can actually be adapted for you. So we'll sort of go through. I mean, we initially sort of discussed how the ease of use and not having to then register those scans because it's all done for us autonomously. Minimal registration, which is crucial when we want to really speed up the time. We get the visual documentation as well, so not only through the video feed, but now through the Pano solution as well, where we can get full 360 interpretation of our environment. The main key thing for me is the time saving. You know, being able to move through a building or externally just by holding a device in your hand and walking at a fast pace to collect all the data. As we saw, it's also available to use across multiple applications as well. So we can cross-reference it through different applications and be able to use it in almost any environment. So I think, Mike, I think we have had some questions. A question about battery autonomy. So sort of battery without interruption. So the Revo RT and the Horizon both come with hot swappable batteries. So they do give us different, because of the Revo RT is obviously, we've got the tablet as well, and it's bringing that data through live. We've got a slightly shorter lifespan. It's about an hour and a half, but as I say, we've got those hot swappable batteries, so we can just bring a new battery in, and you'd probably limit your scan to about 20 to 25 minutes anyway, so you shouldn't really get an interruption there. So thank you for that question. Another question we've got, can I use the GeoSLAM tools underground? Yes, you can. As we saw, you can sort of put it through a roof void, or you can use it underground. It was, I don't know if you want to sort of add anything to that, Mike, but you know.
Yeah, sure. Sorry, Ben. So generally, when you're underground, you are surrounded by lots and lots of geometric features, all in 3D. So you've always got coverage above you, obviously, as well as the features around you. So generally, underground, you get really fantastic SLAM results. That's where the system was originally built for. So for sure, taking it underground is a great idea.
Thanks, Mike. Another question as well. Could I use this on a marine ship, a large ship, and internally? Absolutely. So yeah, I can sort of send you a bit more information and maybe some data as well, but we can certainly use it on a large ship. Probably don't have time to answer all of the questions, but if you have any other questions going forward, then please don't hesitate to contact me. So thanks again to everybody for watching. Any questions at all, you know where to find us, and yeah, please feel free to get in touch. Thanks very much.
Thanks, guys.